Okay, hello, welcome back. So this is another video, section 14.6, sum and difference of cubes. So let me give you the formulas first. Let's talk about sum of cubes. Sum of cubes, again cubes expression bring to the third power. Okay, a to the third power plus b to the third power can be factored as a plus b times a square. Now be careful here. You had plus, the second parenthesis is going to have an opposite sign, which is minus ab plus b squared. Okay, so this is sum of cubes formula. Pay attention to this one. Sum of cubes can be factored. Okay, in the previous section 14.5 I talked about the sum of squares, which can not be factored. Sum of cubes can be factored. So how are you going to factor? You're going to put in the first parenthesis a plus, you're going to follow the sign. We have sum, so the first parenthesis have a plus, b. So we'll have to figure out what is a and b. However, the last parenthesis you have to be careful. Okay, the middle expression, it's going to have an opposite sign of your original. If you had a plus, in the middle you're going to have a minus. And AB. Okay, so let's just write a little note here. Okay, almost like difference of squares. Difference of squares. Okay, so difference of squares, you had a squared minus 2ab. So difference of squares was a squared minus 2ab plus b squared. Okay, and that was a minus b to a second power. That's what I'm relating to it. Here we don't have that too. Okay, so that was sum of cubes formula. Next one is the difference of cubes. Formula, which will be a to the third power minus b to the third power, and you can factor that as a minus b times parenthesis a squared plus ab plus b squared. So let's talk about it. So couple things. Difference of cubes. So the first parenthesis will have a difference. You follow the sign. However, the second parenthesis, if you have a minus, that middle expression will be the opposite of what you see, which will be plus. So again, pay attention to that. So this formula here, this is similar to perfect square trinomial. Trinomial. Perfect square trinomial formula, but without 2. Okay, so let's just review that. We had a squared plus 2ab plus b squared. This is the same as a plus b to a second power. Okay, so that's what we did in the previous section. So two formulas which we need to remember, memorize. Let's just do the examples. Factoring and sum of cubes. So let's work first. Example 1, factoring a sum of cubes. Okay, so a factor w to the third power plus 64. Okay, so first check if you can use a to the third power plus b to the third power formula, which is sum of cubes. Okay, which we can. Yes, we can, because we have w cubed plus 64, which is the same as w cubed plus 64. 64 is the same as 4 to the third power. So a it's equal, I'm sorry, not square, that should be 3. A it's equal w, b it's equal 4. This is your a, this is your b. Okay, just in case if we don't see that, which I hope we will, okay, note to find a, take a cube root. Okay, so to find a, it's equal cube root of w to the third power. So again, the index of the root and the exponents undo each other, you will end up with w. So that's our a. B will be cube root of 64, which is 4, and that's our b. So now we know that a it's w, b it's 4, and we can use the sum of cubes formula. So 2 factor w cubed plus 64, use sum of cubes formula. Okay, we should memorize that formula. A to the third power plus b to the third power is the same as a plus b times a squared minus ab plus b squared. Okay, so in our case, again, a was equal w, b was equal 4, so let's just plug it in. We got w to the third plus 64, that will be equal w plus 4 times w squared minus a times b. Again, let's calculate that. A times b is just w times 4, which is the same as 4w. So minus 4w plus and b squared. B squared is just 4 to a second power, which is 16. Okay, and we factor. That's our final answer. Okay. Okay, let's do example B. Okay, so still we're talking about sum of cubes. Let's just get comfortable with this formula. So we have p to the third power plus 125. So use formula a to the third power plus b to the third power, to the third power, which is the same as a plus b times a squared minus ab plus b squared. And I recommend to rewrite that formula a couple times. That will help you to memorize. So note, a, it's equal, you have to undo that third power. So a, it's equal cube root of p to the third power, again exponent and index of root, undo each other so you end up with p. So that's our a. Okay, let's continue. B, it's equal cube root of 125 which will give us 5. 5 to the third power is the same as 125. So this is B. Now we can just plug it in into the formula. So technically what we have here, p to the third power plus 125, it's the same as p to the third power plus 5 to the third power. So we're going to use the formula. First, a plus b. So in our case, we have p plus 5 times, and then we're going to take care of this parenthesis, a squared minus ab plus b squared. So a squared, in our case, a it's p, so we have p to a second power, that's your a squared. So I'm plugging in right here. That p squared will go right here. Okay, now I'm going to evaluate negative a times b. Negative a times b. So this is negative. In our case, a, it's p. Negative p times b, again b is just 5, which is rewrite that as negative 5p, and that negative 5p goes right here. Negative 5p, it's a times b, negative, and going back to the formula, we need to evaluate next b squared. B squared, in our case b is equal 5, so 5 squared will be just 25. So you take that 25 and you putting in the second parenthesis plus 25. So we have it. This is our answer. P to the third power plus 125, it's the same as p plus 5 times p squared minus 5p plus 25. So p cubed plus 125, it's equal p plus 5 times p squared minus 5p plus 25. That's the answer. We factor that completely. Okay, next what we're going to do, we're going to practice factoring and difference of cubes. That's example 2, factoring a difference of cubes. Okay, factoring difference of cubes. Okay, so we're going to work with the formula a to the third power minus b to the third power. It's the same as a minus b times a squared plus ab plus b squared. Okay, so pay attention that we have a minus and the second parenthesis in the middle has plus. So that's what we have to pay attention to. Okay, example A. Let's factor completely. 27p to the third power minus 1000 q to the third power. Okay, so find A from the formula. So to find A, you take your first expression, which is 27p to the third power, and don't forget to take the cube root. So this is the same as cube root of 27 times cube root of p to the third power. So cube root of 27 is 3, because 3 times 3 it's 9. 9 times 3 will give you 27. And cube root of p to the third power, so index and exponents undo each other, so you end up with p. Okay, now find b. Take the cube root of 1000 q to the third power, which is the same as cube root of 1000, times cube root of q to the third power. So cube root of 1000 is 10, because 10 to the third power will give you 1000. And cube root of q to the third power is just q. The power and the index of root undo each other, so we have 10q. That's b. And now we're ready to plug it into the formula. So 27p to the third power minus 1000 q to the third power is the same as, and now we're working with this, a minus b. So in our case, a was equal 3p minus b, b was equal 10q. So we have it times. Now we're working with this. Second parenthesis, a squared. So we need to figure out what is a squared. A squared is just 3p to a second power, which is 3 to a second power times p to a second power. You're getting 9p squared. So this is a squared, 9p squared. Next, I need to calculate positive a times b. So let's evaluate that. A times b. Again, in our case, a it's equal 3p. So I'm taking 3p. Multiply by b. b, in our case, it's 10q. 3 times 10, we're getting 30 pq. So that's AB right here. Again, we're working with this part of the formula, A times B. So we're getting 30Q. That 30Q goes right here, plus 30Q. I'm sorry, 30PQ. PQ. Okay, and now the last part of the formula, we need to evaluate what is B squared. B squared, again, let's go back. In our case, B, it's 10Q, so we need to square it. Take the 10Q and bring it to a second power. Don't forget to distribute that exponent to both. So that means 10 to a second power times Q to a second power. So we're getting 100Q squared. And that 100Q squared goes inside the second parenthesis, plus 100Q squared. Okay, so this is the final answer. I'm going to rewrite that. 27, so let's put it together. 27p cubed minus 1000 q to the third power is the same as 3p minus 10q times parenthesis 9p squared plus 30pq plus 100q squared. And of course, you can always check, you can distribute the right side, and you should end up with 27p to the third power minus 1000q to the third power. And one more example of factoring difference of cubes. So let's do one extra. Example B, you need to factor 8y to the third power minus 27 z to the third power. So find A. Take the cube root of the first expression, 8y to the third power, so that will be cube root of 8 times cube root of y to the third power. Cube root of 8 is equal to, because again 2 to the third power is just 8, so we're getting 2. And here y to the third power, the cube root of y to the third power is just y, so that's A. Let's save it. Let's find B. Take the cube root, because we're working with difference of cubes, so I'm undo the third power, which means I'm taking the root of third index. So take the cube root of 27z to the third power, which is the same as cube root of 27 times the cube root of z to the third power. Cube root of 27, this is just 3, because 3 to the third power is equal to 27. And cube root of z to the third power will be just z. Again, I mentioned that exponent and index of root, if they are equal, so the solution is just z. So that's B. Now when we know what is A and B, we can go back to this problem and we can rewrite that as a to the third power minus b to the third power by follow the formula. So I like to rewrite the formula a couple times, so that's what help you memorize. A to the third power minus b to the third power is the same as a minus b times a squared plus ab plus b squared. Okay, so we need to factor 8. We need to factor 8y to the third power minus 27z to the third power. So a, we find a, it's 2y, so I'm plugging in 2y minus b, we find b, that's just 3z, times a square, so let's find that a square, so again a was 2y, you need to just bring that to a second power, which means 2 to the second power y to a second power, that will give you 4y square. So a square is just 4y square plus, now I'm trying to evaluate a times b, so a was 2y, b is 3z, multiply that by 3z, so we're getting 6yz, and that 6yz goes inside the second parenthesis right here. So we're putting 6yz, and next, the last part, you need to just evaluate b square. B square. B was 3z, you need to square it, which means bring to a second power 3 and bring z to a second power, so you're getting 9z square. And that b square, which is 9z square, goes right here. Okay. Okay. So we're getting equal 9z square. That's what we're having here. Plus 9z square, and we have it. Okay, so that's our final solution. 8y to the third power minus 27z to the third power is the same as 2y minus 3z times 4y squared plus 6yz plus 9z squared. So this is the end. That's it. We're not doing more. That's it from section 14.6. You only have one video. Thank you for watching.